Today we will talk about the first question in Codility, binary gap. Let's first read the question. A binary gap within a positive integer n is any maximal sequence of consecutive zeros that is surrounded by ones at both ends in the binary representation of n. For example, number 9 has binary representation 1001 and contains a binary gap of length 2. The number 529 has binary representation 100001 0001 and contains two binary gaps, one of length 4 and one of length 3. The number 20 has binary representation 10100 and contains one binary gap of length 1. The number 15 has binary representation 1111 and has no binary gaps. The number 32 has binary representation 100000 and has no binary gaps. So now let's understand what they're trying to get us to find. Given a positive integer n, return the length of its longest binary gap. The function should return 0 if n doesn't contain a binary gap. For example, given n equals 1041, the function should return 5 because n has binary representation 100000010001, and so its longest binary gap is of length 5. Given n equals 32, the function should return 0 because n has binary representation 100000, and thus no binary gaps. Write an efficient algorithm for the following assumptions. N is an integer within the range 1 to around 2 billion. Okay, so now that we know what we're looking for, we'll be given an integer n, and we want to return the largest binary gap in this integer. Let's come up with this approach step by step of how we want to solve it. So one, we want to convert the integer to binary. Second, to iterate through it, I think the easiest way would be to convert the binary into string. And third, we want to iterate through the binary representation and keep track of the largest binary gap, if any. And of course, we start by assuming there are no binary gaps. And lastly, we will return the largest binary gap found in the end. Okay, so now we have an approach. Let's come up with some cases and edge cases that we could use to test our code. So cases that I can think of right now is one, no binary gaps. So this is definitely an edge case. So for example, they used 32, I guess. Single binary gap. And we can say more than one binary gap. Incomplete binary gap. Incomplete binary gap. Okay, so now we have the test cases. Let's write out the algorithm we want to use to solve this question. So I would start with a bit of the conversion. So convert the integer to binary. So I'm going to say binary rep is equal to binary of n dot to string. Assuming we'll be using library functions for those later. Then they iterate through the binary representation and keep track of the largest binary gap, if any. Start by assuming there are no binary gaps. So we're going to assume max gap equals 0. And probably also going to need a temp variable to keep track of the current gap count. And we're going to, iterate through the char in binary rep. And we want to know that if the current char is equal to 1, then we want the gap, or if the current is 0, gap plus equal 1, else then if the current is 1, then we either have to end it. If gap is greater or equal to 1, then we're gonna end. And if gap is greater than max gap, then we're gonna replace max gap equals gap. However, if gap is not, we just continue because it's consecutive once. But before this, we need to have a Boolean. 1 detected equals false. If we don't, so if not 1 detected, if char equals to 1, then 1 detected equals true. However, if we don't detect a 1, we should just continue. So this would just all fall under the else branch. Else. Okay, for char in binary rep, if 1 detected is false, if 1 detected, well, I think this is the wrong place in the loop, this should be here. For every char, if we don't see a 1, if 1 has not been detected and the current char is a 1, then 1 detected is true, or else we have to keep going until we detect a 1. Else, that means we already saw 1, and we should start counting the gap. I think here we have to reset the gap to 0. Gap equals 0. So if the current 1 is 0, gap plus equals 1, or if the current is 1, and if we already started counting gaps, then our gap has ended. So this actually needs to be here because we want to reset the gap no matter if the current gap is greater than a max gap. And if we already saw 1, but we never started counting the gap, then it's just consecutive ones. So we will continue. Okay, so last but not least, we need to return the max gap. So we would return max gap here. And we may or may not be done. Next, we will look at the cases that we have determined above and plug them into our algorithm and see if they work. Now we have an algorithm and we already listed our cases. Let's plug in each case and see if our algorithm is robust. For case number 1, we have no binary gap, so we start with 1. So assuming this all works properly, we would start with 1 detected is false. We would get 1 for the first char in the iteration, and this would be false. And we would enter this branch because the first char is 1, and then 1 detected would become true, and that would end the iteration. And then the second iteration, we would get 0 for the char, and we would get into this branch because now 1 detected is true. And we will also go down this branch because the current digit is 0, and our gap would be plus 1, so now gap would be 1. And that ends our second iteration. On the third iteration, we would have another 0 for the char, and we would also go down this branch because 1 has been detected, that will remain true. And if current gap is 0, so we also hit this again, and gap would be 2, and so on. So for the next 4 iterations, we would just increment the gap. However, because we never get another 1, we would not hit this branch, and we would just end up returning max gap of 0. So it looks like case 1 will work. Okay, let's look at question 2, or case number 2, single binary gap 10001. So knowing that from above we will have hit gap equals 3, and on the last iteration we get char equals 1, and then we would hit this branch because 1 has been detected, and then we would skip this branch because the current digit is 1, so we would hit this else branch. And at this point our gap will be 3, so this will be true. And 3 will be greater than 0, which is what max gap is at this point, and the max gap will become 3, and gap will become 0, and that will end the iteration, and then we will return max gap of 3. So it looks like case number 2 will be fine as well. Okay, so now let's look at case number 3, more than one binary gap. First, we know that after the first couple digits, we will have 1 detected is true. We will have max gap equal 1 because we already experienced the first couple iterations, and we already found a max gap. So max gap will be 1, gap will be 0, and now at this point we hit 0 again, and it will hit this branch because 1 has already been detected. Current is 0, so gap will be again 1 because it has been reset to 0 on the previous iteration. On the next iteration, char will be 1 again, so those will be the last digits in the string, and we will again be in this branch, and we will hit the else because the current digit is 1. And because our gap will be 1, then we will hit this line, but because 1 is not greater than 1, we will not be setting the max gap. And then we will return the max gap of 1, which is correct for case number 3. So in this case, the max gap will indeed be 1. Okay, now let's go on to case 4, incomplete binary gap. After the first 3 iterations, we will have max gap equal to 1, and we will have 1 detected equals to true, and our gap will have reset to 0. So when we get to this 0, we will be in this branch, and current equals 0, so gap will again be 1. And on the next iteration, we will have again gap plus equal 1, so gap will be 2. However, there are no more digits left, so we will end up just returning the max gap, which is 1 in this case, and that is correct for 10100. Okay, now let's go on to case number 5. Biggest binary gap is at the end. So for this one, we already know what 10100 will look like because we just did that example up there. So we will have max gap is 1, and we will have hit this branch twice, and our gap will be 2. And once we hit the final 1, we will be in this branch and we'll be in this else branch because the last digit is a 1. And our gap is greater than or equal to 1. That is true. Our gap should be 2. And our gap is greater than the maximum gap, which is 1. So 2 is greater than 1. So max gap will be equal to 2. And then gap will reset to 0. And we will return 2 as the maximum gap, which is true for this test case. Okay, now we move on to case number 6, consecutive ones in the number. So we start with 1, 1, 1, 0, 1, 0, 1. So let's see if this works. So we start with 1. So we will go down this branch and what will become detected is true. And then the second iteration we hit 1 again. So we will hit this branch because 1 is detected has been true. So we will hit this branch because our current digit is 1. However, our gap is not greater or equal to 1. So we will hit this branch and we will hit the continue statement. So we will go on to the next one and we'll hit this again because it's the same as before. 1 detected is true, so we'll hit here and we'll hit this because our current digit is 1. And because gap is 0, we will hit this continue statement. Now comes the interesting part. We hit 0 now. Will this work? So if the current char is 0, we hit this statement. Gap will become 1. Okay. And then we will hit this 1. And we will hit this branch. At this point, max gap should update to 1. And gap will reset to 0. And then we hit the 0, which means we will hit this branch again and gap 1 again. And lastly, we will hit another 1. So on the final iteration, we will find we hit this branch again. However, because our max gap is already 1, we will not be updating the max gap. And we should return a max gap of 1. Okay, let's move on to case 7. Biggest binary gap is at the beginning. So for this one, we can assume that at digit number 2, we will find gap equals 2, and we will hit this statement when we get to the 1, and our max gap will be 2. So when we hit this 0, we get, if current is 0, gap plus equal 1. So gap will be 1 again. And when we hit this 1, we will hit this statement. However, because this is not true, so our max gap will not be updated. And we should be able to return the max gap of 2. Let's do the final test case 1111. So for this one, we will go into this branch first, and 1 detected will become true. And then we will hit this branch, and we will continue to hit this branch. And because gap will never be more than 1, we will continue to hit the continue statement, and then we will return the max gap of 0, which is the correct answer for this case. Okay, so we have done a lot of work already. Let's try to take a shot at the solution. Okay, I'm going to run the code now and just see if it actually works. Okay, looks like it worked for the test cases that they have provided. Okay, so now we have passed the basic test that they provided us. Let's also use their testinput.txt and put in the test that we have. So I'm just gonna use a converter to quickly convert these to decimal. Okay, so now we need to determine if they pass the test. 0 is correct because this one has no binary gaps, this one has a binary gap of 3, this one is a max gap of 1, this one has max gap of 1, this one has max gap of 2, this one has max gap of 1, this one have max gap of 2, and this one has max gap of 0 because there's no binary gaps. Okay, so I'm gonna try to submit this task and see if I get anything. Okay, so it looks like it got correctness in text of 100 and performance was not assessed. Okay, so this one did not give me a big O notation or anything.